All right, so now let's try a problem. We're going to be asked to find the approximate area under the curve of this function from 0 to 2 using 4 subintervals. So this is how all the problems now are going to look. You have some function, and they're going to ask you to find the left, the right, or the midpoint. And so we're going to look at each one individually so that you can figure this out. So our function's given, it looks like this, and you can see part of it now is below the x-axis. So what does that mean? That means you have negative heights, which means we would get a negative area. It looks like this graphically. So you can see this is negative and this is positive. And so when we do our left, this is what we're going to get. You can see there's our first left, next left, which is actually at 0, and next left. And then we're also going to do right. And so that would be our right, our right, our right, and our right. And then we're also going to do midpoint. So let's give this a shot. So we're going to start with the left. So again, we're going to go from 0 to 2. So we draw our line from 0 to 2. And you always want to graph these first to get a picture of what's going on. It lets you know if you're doing things correctly. And then we break it into our 4 subintervals. So you're going to go from the x-axis to the function itself. So that one's at 0. We don't do anything. And then that one we go up. So you're always going from the x-axis to the function itself. And then like I said before, if you're doing a left, you start at the left and we draw our rectangle, and then you just keep going to wherever those lines intersect our function and just continue on. So that one's just a line. So what happens when you hit 0 is you just draw a line at 0. So if the graph itself is a y-intercept at where you're looking at, or an x-intercept where you're at, just draw a line straight across, and then we're filling these in. So what I like to do is use red for when we go down, and blue. And so I can't draw anything because it doesn't go up to that point. And then blue here. And if you get confused again, use the Desmos graph to figure it out. So you can see this is our left, goes across, our left goes across, and then that one is an intercept, see? So at 1, we're going to get 0, so the height would be 0. And then this one at 1.5, that would be our height. So you can see that these are negative heights. So we're going to get negative area, no area, positive area. All right, so let's write these out now. So our areas, again, we have to do our subinterval. So it's going to be area, and it's width times heights. And so when you find the width, what you want to do is take your B, subtract your A, and then divide it by your subintervals. So this is our B and this is our A, wherever we're starting and ending. So this would be 2, take away 0, divided by 4 subintervals would give us a half, or 0.5. So if you can't see it on the graph, using that little formula will tell us what it is. So you can see right here it's 0.5. Now what we need is our heights. So our first point that we're plugging in from the left would be 0. And so all you have to think is 0. And then our width is 0.5. So we're going to be 0.5 away from it. So f of 0.5, f of 1, and then f of 1.5, because we're just working from the left across. So whatever our width is, we're just going to be adding it to each of our points and plugging it in our calculator. So I'm going to shrink this so we can have room to our calculator. Right there. So we plug in our function, we hit window, and we go from 0 to 2. That is our partition. And then we have already our lowest is negative, our highest is positive. So if we hit zoom fit, which is zoom 0, it's going to graph exactly what we need from the lowest to the highest. And again, we can use the table function to do this. I mean, you can even just use Desmos. So we got -3, -1.75, 0, and 2.25, because it's just the left endpoints, the intersections of the function with our rectangles. So we could just use those as well, but I want to keep this with the TI. So if we hit trace and 0 and hit enter, we say it's -3. So our first point, our first height is -3 plus, that's going to be a minus as well, so we might as well just leave it as empty. And then trace, and our next point is 0.5. Hit enter, and it says -1.75. And the next one is 0. We don't have to plug it in, but we can if we want to. So trace 0, and you'll see, oops, trace 1. It's 0. And then 1.5, trace 1.5. It's 2.25. So now we have all of our heights. We can plug this in our calculator, and it will give us our approximate area. And we get negative 1.25. And so there is our approximate area. So now let's try it with a right. So same thing, same function, same interval. So it's just going to be a mirror picture down here, but now we're going to be using the right. So we're going to start on the right. So that's our first intersection point. Draw across, right? We got to make sure that we cut it into 4 subintervals. So there's our first one. And so the next one will be right there where we connect. You can see that they just intersect at those points. And so then the next one, that would be our right endpoint. So again, it's 0, just right there. And then the last one would be right here, cutting across and there. So we end up with the negative here. So to get a clearer picture, again, we start with the right endpoint here, go across and down, and then that would be our next endpoint. So you're just following the function, and where each of our little points hit within those subintervals, that's what you want to pick. So that would be our first rectangle, our next rectangle. That one was 0, so the height would be 0. And then that one is negative 1.75. And so you can see there it is. So again, all the points we're going to plug in, even if you don't have a picture, are just those values. So we're going to go a equals 0.5. And then our first point would be the 2, because that's where our subinterval starts. So this would be f of 2. And then we just work our way down by subtracting that value. So 1.5, 1, and then 0.5 is our final one, and we don't actually get to 0. So you can see that with the left, we start on the left, which was 0, and work our way across, and so we're 0.5 away from the last point, because that would be for the right interval. And with the right, we start at 2, and work our way down until 0.5. So even if you don't have the picture, you know what values to plug it in. And so now you can look at Desmos for those values, but again, we're using the calculator. So we're going to go back to our graph, and we're just going to trace it in. So trace 2, and it's 5 plus, and then we'll do 1.5. We already had the graph, so it makes it easy. 2.25. And then 1, which we already know is going to be 0 from before. So 0. And I know we have all these up there, but I just want to have the process down. So 0.5 has already been entered as well. So we just do trace 0.5. So you just work your way down. Trace 2, trace 1.5, trace 1, trace 0.5. Hit enter because we're working from the right. So negative 1.75. Erase that. Negative 1.75. Now all you have to do is plug that in your calculator, and it'll give us our approximate area under the curve. And so we end up with 2.75. So you can see this one overestimated more positive and the other one overestimated more negative. So let's now try midpoint. So same thing, we're going to break it from 0 to 4. So right here to 2, sorry, 0 to 2, and then we break that up into 4 parts. So again, from the line, and so that one is just 0, and then straight up. Okay, so in the first partition, this would be the first subinterval, that would be 0. So we draw our rectangle, and again, that would be negative. And then the next one, that would be the midpoint. So we draw across. And so there we go. And then the next one, that would be the midpoint. We draw it across. And there we go. And then this one would be the midpoint. And we draw it across. Oops, why are these in red? They're supposed to be in blue because they're positive. There we go. I got lazy with the colors. All right. So now you can see that we have a much more balanced situation going on here. And so now we're going to use the calculator. But when we use the calculator, you can do trace if you want. So that would be 0.25, and then we add across. I'll show you 2 different ways of doing this. So just so we have it, our area is still a width of 0.5, and now the heights. So what you want to do is the midpoint here. So if you have 0 to 0.5, if you add those and divide it by 2, it'll always give you the location of the middle. It's the average. So our first one is at f of 0.25. Now you probably could have already seen that yourself and known that was it. And then all we're doing now to find each point is we know our width is 0.5. So we're just going to take that 0.25, add 0.5, and we get the next point. And then we're just going to keep adding 0.5 to it to get to the next point, because our width is 0.5. So now we have 1.25 plus 0.5, which should give us f of 1.75. And each of these should match perfectly. You can also do the midpoint thing for each one. So if I did 2 plus 1.5, that would be 3.5. Cut in half would be 1.75. But you're trying to find these x values right there. So however you do this, it's your choice, but you need to find those values to plug them in the calculator. So now we can go back to our calculator, put our graph back up, and then hit trace 0.25. Hit enter. And we get negative 2.4375. And we move on. The next one's also going to be negative, and then we would have positive and positive. All right, so now we can fill it in nicely. So 0.75 this time. And that gives us negative 0.9375. It's 0.93. I'm like, that's way too big. 0.93, there we go. And then trace 1.25. So the table here is going to be a lot quicker on these, 1.0625. And you have to find the method that you like the best. So for me, I like looking at the picture. 3.5625 to make sure everything matches. All right, but you can just use your table. So think about it this way. Our first value is 0.25. So if we go to our table, we're going to start it at 0.25. And our change in table is our change in x here. And so our change in x is 0.5. And so now what it'll do is start at 0.25 and add 0.5 all the way across. So if you go to your table, there's all our values. So 0.25 was negative 2.3, and then negative 9.375, and then 1.0625. And then the final one, which is 1.7, is 3.5625. And you can use this for all of them. So if you want to do this for left, right, and middle, it's just whatever your starting value is, and then all the way across. So this one we want to put 0.5. So if I go to table set, my first one would be 0.5. My change in table is 0.5. It's the same change in table for all of them, because that's your change in x. And there you go. So negative 1.75, 0, 2.25, and 5. And you can even do this if you wanted to. You could do table set, make it 0. That's our first one here. Hit second table. And now you can see that our left would be negative 3, negative 1.75, 0, and 2.25. And then our right, we would just start at the right. So 5, 2.25, 0, negative 1.7. So now let's find out what this is in our calculator. And it's 0.625, which looks like a much better estimate than over the other two. This one's just really positive. This one looks really negative, and this one's nicely matched. So let's check our calculator. We go to our graph. And remember, we want to shade these areas. So second calc, number 7. And then our left would be 0. Our right would be 2. And it will shade. Giving us 0.66. So this tells us we did a good job. It's pretty close. So if we did more rectangles again, we'd have a better area.